This is the 15th session on friction. In this video also I will take up a numerical problem on kinetic friction. Okay. First what I will do, I will write down the question and then I will solve it. Okay. So the question is this. Question is this. There is a fixed rough inclined plane which makes an angle alpha with the horizontal two blocks of masses m1 and m2 are placed over this rough inclined plane as shown below. Okay. Now what I will do, I draw the diagram of the situation. This is the horizontal direction. This is the fixed rough inclined plane. This makes an angle of alpha with the horizontal. There are two blocks of masses m1 and m2. This is block 1 of mass m1 and block 2 of mass m2. Both are in contact over this rough inclined plane and they are also in contact with each other. The friction coefficient between block m1 and inclined plane is k1 and that between block k2 and inclined plane is k2. Okay, and it is given that k1 is greater than k2. This is given. Now two things we have to find out. Okay, I'll rub this one. Alright, this I have stated it. Okay. Now two things we have to find out. First, find the interaction force between the two blocks in course of motion. Force between two blocks in course of their motion. And second thing, minimum value of angle alpha at which the blocks start to slide down the plane. Of angle alpha at which the blocks begin to slide down the plane. To slide down the plane. I'll rub this one. Okay. Slide down the plane. Okay, so these are the two things which you have to find out. Everything else is given in the problem. Mass of two blocks are given m1 and m2. Inclined plane makes angle of alpha with the horizontal. K1 is the friction coefficient between this block and inclined plane. And K2 is the friction coefficient between this block and inclined plane. And they are released from rest. They begin to slide down the inclined plane and both are in mutual contact. These two things we have to determine, we have to find out. All right. I'll rub this one, okay? So what is going to be our approach? Approach to solving this problem will be this. What I'll do, I'll draw the free body of these two blocks separately in ground frame. And then we apply Newton's second law of motion to both the blocks down the inclined plane with respect to ground frame. And solve the resulting equation to solve the two parts of the question. Okay. So first what I do, I draw the FBD of these two blocks. So I'll draw the FBD here. Okay. So this is the horizontal. This is the inclined plane. This is the angle alpha. This is the block of mass m1. So FBD of first block I am drawing m1g. Normal force n1 on this block due to the inclined plane. This block slides down the inclined plane. So this block slips with respect to inclined plane down the inclined plane. This inclined plane exerts a friction force F1 on this block. And this block M2 exerts force M1 on this block down the incline, say F. Is the interaction force which M2 exerts on M1, which we have to determine in part A of the question. So this is the FBD of this block of mass M1. Similarly, I draw the FBD of this block of mass N2. This FBD of mass N2 I draw in a separate diagram, okay? I don't write here just because it becomes very clumsy, okay? But M2 is in contact with M1. This one point should be noted down. So I draw the FBD of this block of mass M2, okay? This is the inclined plane. So FBD of mass M2 is this, M2G, N2. This block slides down the inclined plane with downward direction. So the inclined plane exerts a friction force F2 on this block up the inclined plane, opposite to the direction of relative slip. And this block M2 exerts interaction force F on this block down the inclined plane. From Newton's third law, this M1 will exert equal opposite interaction force F on this M2. So this F also acts on M2 due to M1. In part 1 of the question, we have to determine this F. Alright, fine. I'll rub this one, okay? So all the FBDs have been drawn. Now what I do, I apply Newton's second law to this block down the inclined plane. Okay. So in that net force on the block down the inclined plane will be component of it down the incline, which is m1g sin alpha plus f minus f1. That is equals to m1 times a. Alright. So m1g sin alpha plus capital F minus f1 is equal to m1a, where a is the downward acceleration of block down the inclined plane with respect to ground. Now this block is slipping over this rough inclined plane. So friction force F1 on this block due to inclined plane is K1 times N1. Okay, because rule of kinetic friction. When slipping takes place, then kinetic friction is equal to mu times N. Friction coefficient due to normal reaction. Now to know F1 we must know N1. Now how to find N1? To find N1, what I do, I apply Newton's second law to this block with respect to ground in this direction. In this direction only forces are N1 and M1g cos alpha. These two forces do not have any component in this direction because they are right angles. So in this direction I apply Newton's second law to this block with respect to ground. N1 minus M1g cos alpha is equal to M1 into acceleration of this block with respect to ground in this direction, which is simply a cos 90 degree. But a cos 90 degree is 0. So this becomes 0 right side. So if you solve this equation, N1 becomes M1g into cos alpha. Now this N1 I substitute here. So I get F1, K1 times M1g into cos alpha. Now this F1 I substitute in this formula. Alright, fine. I rub this, all this, okay? This much part I rub, okay? This F1 I substitute here. So what do we get? M1G sine alpha plus F minus cos alpha is equal to M1 times, so this is the first equation. Okay. Now what I do, I apply Newton's second law to this block B2 of mass M2 down the inclined plane with respect to ground again. So down the inclined plane, what are the forces? M2G sin alpha minus F minus F2. Okay. So what do I write? Sin alpha minus F minus F2 M2 into acceleration of this block with respect to ground down the incline. But B1, these two bodies are rigid and mutual contact and they are moving along straight line. So acceleration of these two blocks will be same in magnitude and direction both. But acceleration of this block has been assumed to be A down the inclined plane. So acceleration of this block with respect to ground is also A down the inclined plane. So here we write M2 times A. Alright. Now I rub this one. Now we should remove F2. Now this block slips over this rough incline. So F2 is the kinetic friction of this block due to incline, which is simply K2 times N2. Now to know F2 you must know K2. How to find K2? N2. We apply Newton's second law to this block along this direction with respect to ground. So in this direction F2 and F do not have any component. Only components are these two forces they have in this direction. So what do I write? N2 minus M2G cos alpha. Cos alpha is equals to M2 times acceleration of this block with respect to ground in this direction. But acceleration of this block with respect to ground is A down the incline. So component of A in this direction becomes A cos 90 degree. But cos 90 degree is known to be 0. So this term goes away. So right side becomes 0. Okay. So from this, now I love this one. Okay. So N2 becomes N2G cos alpha. Now this N2 I substitute here, I get F2. F2 is K2 times M2G into cos alpha. Now this F2 I substitute in this formula. So what do I get? M2G sin alpha minus F minus K2 M2G cos alpha is equal to M2A. This is the second equation. Okay, fine. Now we have to determine the friction interaction force between the two bodies. So from this what we can do, what I do, I divide the first equation by second equation. So I divide first equation divided by second equation. So what do I get? A will be eliminated. Okay. So what do I get then? So I get M2G sin alpha minus F minus K2 M2G cos alpha upon M1G sin alpha plus F minus M1G cos alpha. Now this all I rub, okay. This all I rub this much, okay, fine. So when I divide this second equation by first, I should have written here 2, not 1. Second by third I am doing, no? Okay. Because this I have mistakenly written. 1 divided by 2, it's 2 divided by 1. Okay. So this becomes what? M2A divided by M1A. M2A by M1A. A and A cancels out. Alright, fine. Now I multiply this equation, cross multiply and solve this equation for F. So what do I get? M1 M2 G sin phi M1 into this minus M1F minus K M1 M2 G cos K M1 M2 G cos alpha K2 M1 M2 G cos alpha uh, this space is finished. I'll rewrite it here again. Okay. So this is the equation. Now multiply this. Now this also I have. Okay. Fine. So now I multiply this both sides. Okay. This I multiply this and this. I cross multiplication. So what do I get? I'll rub this equation also. Okay. This I'll write it here. So that I get more space. So I shall write this equation here. Plus f minus k1 m1g cos alpha is equal to m1a, first equation. Okay. I'll rub this one. Okay. Now cross multiply these two equations. How much it becomes? m1 m2g into sin alpha minus m1f minus k2 m1 m2g cos alpha, k2 m1 m2g into cos alpha, that is same as m2 into this m1 m2g sin alpha m2 into f plus m2f minus m1 k1 m1 m2g cos alpha, k1 m1 m2g into cos alpha. Now m1 m2g sin alpha cancels out in both sides. Alright, fine. Now I can solve this equation for f. Now rub this equation here. Okay. I solve this equation for f here. Okay. This equation. I bring f this side and remaining term that side. Okay. So what do I get? I bring f on both sides, on one same side. So it becomes f bracket m1 plus m2. Okay. Fine. That becomes how much? This term goes that side. So this becomes k1 m2g cos alpha minus k2 m1 m2g cos alpha. Alright, fine. Now I rub this one. Okay. So on solving this equation, what do I get? If I solve this, so f is equal to, here m1 m2g cos alpha becomes common. This is m1 m2, m1 is also m1. Okay. So m1 m2g cos alpha into k1 minus k2 upon m1 plus m2. This is the answer to the first part of the question. Okay. So this is the interaction forces between the two blocks. So interaction forces between the two blocks is equal to m1 m2 g cos alpha into q1 minus k2 m1 plus m2. First part of the question has been fully solved. Is it alright? Now second part, we have to find out what is the minimum value of angle alpha so that the two blocks begin to slide down. Okay. Now I rub the all other portion. I just let equation 1 equation to remaining I rub it. Okay. This also I rub it. Now in second part of question, what I do? I add first and second equation. Equation 1 plus equation 2. If I add, what happens? F will go away. You can see. So what do I get? m1g sin alpha plus m2g sin alpha. Okay. F cancels out. Minus g cos alpha k1 plus k2. I suppose it is alright. G cos alpha becomes common. K1, I'll just check the equation. Okay. So sorry. This becomes g cos alpha is common. I add these two equations. So g cos alpha is common. K1 m1 plus k2 m2. That is equal to m1a plus m2a. That simplifies to this much. Okay, fine. Now I rub this one, okay? Now it is given that the blocks are moving down the incline in mutual contact. So A is definitely more than 0. So this means, since mass is a positive quantity, this means m1 plus m2 into A is also more than 0. So this means this quantity should be more than 0. G is common, G sin alpha is common, into m1 plus m2 minus G cos alpha into k1 m1 plus k2 m2 is more than 0. Alright, I rub this first column. So now G cancels out, so we get m1 plus m2 into sin alpha minus k1 m1 plus k2 m2 into cos alpha is more than 0. So this means m1 plus m2 into sin alpha is more than k1 m1 plus k2 m2 into cos alpha. I divide by cos alpha, sin alpha by cos alpha becomes tan alpha from trigonometry. So I get tan alpha is more than k1 m1 plus k2 m2 by k1 plus k2. So this is the minimum value. This is the minimum value of tan alpha. Okay. I rub this one. So this means alpha should be more than tan inverse k1 m1 plus k2 m2 by m1 plus m2. This is the required minimum value of alpha, so that the blocks start to begin to slide down the inclined plane. Okay, so alpha should be minimum this much, so that the two blocks will then go down together. Okay, so these two parts of different question has been fully solved, or this question has been fully solved. Okay, so go through it properly. In case you have some doubt, put your doubt in the comment box, I'll solve them. Okay, let's close it here. Fine.